Hopefully today in class we talked a little bit, or we did an activity to visualize what this would look like with squares perpendicular to the x-axis. So what I'm going to do here is calculate the volume of that solid that would be formed if I were to do an infinite number of tiny little post-its sticking up like we had in class today. So the first thing I need to do is decide whether I've got dy or dx. My squares are going to be like this, right? And they're going to stick up out of the paper, and I can't really draw them on here all that well, right? But you should be able to visualize what they look like from our activity today. They would be much shorter down here, and they would be the tallest somewhere in around here. So, I'm taking these squares like this, and they stick up out of the graph. They are, since they're perpendicular to the x-axis like that, that actually tells me that we've got a dx, because I'm going to do this square, and then I'm going to do this square, and then I'm going to do this square, and I'm going to add all those up, right? So I'm going to add them up over, or add an infinitely small number of them up as we go along. Like, I'm going to have an infinite number of boxes, and they're going to be infinitely thin, you know, like this way. So, in order to tackle this, I'm going to use this length right here. Because what I argue to you is that this length right here is going to be the same as the height, and I'll draw it, of the little rectangle of the square that's sticking up. So this height and this thing are the same thing. So what I can do is find the area of each of those little post-its that stick up. So that height is going to be the base of that region, or the base of that square is going to be this distance right here. So that's going to be the top line minus the bottom line, which is going to be actually the line y equals 2x minus the line y equals x cubed over 8. And now I argue to you that each of those squares, area of each of those individual squares, is equal to that side length squared, where this is that side length. So what I'm going to do, so this thing is going to go in here, and that's going to be the area of one of those squares. What I want to do to find the volume is add up all of those side lengths squared over dx from this spot to this spot. I think it's pretty clear that this is 0, 0. If you set these two equations equal, you get that this is 4, 8. So since I'm going dx's, I start at 0, which is this, and I'm going to go all the way out to here, right? So I'm going to add up all these little squares areas all the way out to here. So that's going to take me to here. This x value is 4. Right? And my side length squared is this thing. So this is going to go in right there. So I get integral from 0 to 4 of 2x minus x cubed over 8 squared dx. Now I just have to evaluate that integral. I chose to do it using my calculator because it is it's quick. And I did fn int, you know, plugged everything in correctly. The one thing you have to make sure that you do is that you include that in the right spot, that squared value. And when I plug that into my calculator, I get 19.505. So the next video is going to talk about doing it with squares that are perpendicular to the y-axis. So I want you to think about how things might change. I'm still going to do a difference to find that side length for each of them, but I'm going to subtract things in different ways. And instead of having all of these things along the x's, oops, I'll undo all those. Instead of having all the blue guys along the x's like that, all of those little post-it notes that we have sticking up, all the little post-it notes are going to go this way. So think about how that's going to change the nature of the problem for the next one.